Let's see what happens when we solve one with two unknowns. I'm looking now at focus exercise 5, and it's the same thing as before, where we need to read through and figure out what's going on. So let's start the reading. Maurice, the barber, has a few different retirement investments. When he turned 70, he decided to cash in 2 of them. He received $10,000 more from his Pepsi stock than from his McDonald's stock, for a total of $92,000. How much did he receive from each investment? Notice that the question is, how much did he receive from each investment? How many investments? That's right, 2 investments. 2 unknowns. We don't know how much he got from each one. 2 unknowns. So when we go to set this up, we're going to have a let x equal something, and then we're going to have something else for the second unknown. How do we determine which one's going to be x? Do you remember from section 3.2? You do. Good. That's right. Yeah, that's right. X is going to be the second thing mentioned. So let's see. We have here that he received $10,000 more from his Pepsi stock than from his McDonald's stock. There is x. So I'll say let x equal the amount, I'll abbreviate that, from McDonald's stock. I'll abbreviate that a little bit. So the other part must be the amount from the Pepsi stock. But how much? Not x. How much? We look for that phrase of comparison or sentence of comparison. When we have 2 unknowns, there's always got to be that, how they compare to each other. He received $10,000 more from his Pepsi stock than from McDonald's. 10,000 more. That suggests what? Yeah, that's right. Adding 10,000. So to what? Yeah, to the x. To the x, that's right. X plus 10,000. That's the amount from his Pepsi stock. Now, drawing a diagram, I don't know, maybe something like this. We'll say, here's what his stock looks like. Usually it's just, goes from one account to another, but we'll pretend it's a piece of paper. And on here we have McDonald's, and we have Pepsi. And the amount that we received from McDonald's is X dollars, and the amount from Pepsi is X plus $10,000. Now there is one more piece of information that we don't see in the diagram, which we could certainly write there, but we don't see it as yet, and that is what? So we got the 10,000 more than his Pepsi stock at McDonald's for a total, there it is, total of $92,000. So let me just write that in here. I'll say, okay, total equals 92,000 big ones. Okay. So, based on that, let's see, a formula. Well, we don't really have a formula for stock so much, but we do have what I call the generic formula. And the generic formula is this: the sum of the parts, actually the sum of all the parts, equals the whole. I call that the generic formula because it's just something that so many other formulas are based on. It's just this idea that the sum of all the parts equals the whole. And so with that in mind, what we're looking at are the parts, in this case, are the McDonald's stock plus the Pepsi stock must equal the total. And, the amount from the McDonald's and the amount from Pepsi. And we can put that in the chart also. Here's McDonald's, here's Pepsi, and total. And again, what we saw is McDonald's is X, Pepsi is the x plus 10,000, and the total is 92,000. So when we put that information, actually put an equal sign right here if that's helpful, and put a plus sign there if you want, but when we put it back into the equation, again, McDonald's is x plus Pepsi is x plus 10,000, and the total is 92,000. And again, we simply have an equation, and we have to solve the equation. So we go about our business and what we learned in Chapter 2 about combining like terms in this case, and then we'll isolate the variable. So right away we'll get 2x plus 10,000 equals 92,000. And we'll isolate the variable first by subtracting 10,000 from each side, or if you want to think of it as adding a negative 10,000, that's good. And we have here 2x equals 82,000. And we can divide each side by 2. And in doing so, x is 41,000. Well, here's an important piece again. We've said x is 41,000, yet we have two unknowns. So which does the 41,000 belong to? Which amount? Is it the McDonald's stock or the Pepsi stock? This is why we have our legend. We can go right back up to here and say, oh, x is the amount from McDonald's stock. And in our chart, we can even write that in there, that the McDonald's stock is 41,000. Remember, the chart is here to help keep us organized in our work. Pepsi is x plus 10,000. That's the 41,000 plus 10,000 more is 51,000. And think about that. If you were to add these two together, would they add up to 92,000? Yes, they would. And Pepsi is indeed 10,000 more than the McDonald's. So we can be confident that we've got the correct answers here. But again, it's the coming to the answer and then referring back to the legend, or maybe even to the chart, that helps us figure things out. And that's why we write the legend as we do. Okay? Got to complete this problem. Answer the question. How much did he receive from each investment? We can say this. Maurice received $41,000 from his McDonald's stock and $51,000 from his Pepsi stock. Okay, there you go. We're not done. Nope, that's just the second example. Or exercise. I've got two more to do, actually. And I hope that you'll stay with me and watch those. So let's go on to the next exercise. This is Focus Exercise 8 from Section 3.3. You can see there it's on page 18. And let's read. April has, after 2 tests, an average score of 81. If her second test score was 12 points higher than her first test score, how many points did she score in each test? Now, just like all the others, I didn't mention this before, but I'll mention it now, you're not expected to know the answer right away. You know, the question is, how many points did she score in each test? And your answer probably is, I don't know, because we don't know yet. That's my answer too. I don't know. But I'm going to find out. And I'm going to find out, you know, taking things step by step, identifying the number of unknowns. In this case, there are 2 unknowns. We have her second test score and her first test score. So that's why I wrote up here 2 unknowns. And with those 2 unknowns, we have to have a sentence of comparison. Let's see if we have a sentence of comparison. Second test score was 12 points higher than first test score. And the second thing mentioned, that's the x. Right there. So we could say, let x equal the second test score. And so whatever we find for the next one, that's going to be the first test score. But how does it compare? Let's see. Second, oh gosh, you know what? I messed up. Did you notice that? I messed up. Let me correct this as best I can. I'm going to change these out. Change those out. Well, I said it, but I didn't follow it very well, did I? X right here is the first test score. So this should have been first test score for X. And her second test score, that's going to be 12 points higher than. That'll be X plus 12. Okay. I feel better already. You too? Yeah, I thought you would. Okay, well, let's see. Let me draw in her tests. This is what we've got for April. First test, second test, and what is the score? Well, our score on our first test is simply X points. And on our second test, it's X plus 12 points. And there's one other important piece of information, and it comes in the very beginning of the problem. It says April has, after 2 tests, an average score of 81. An average score of 81. Well, this is a different kind of formula that we haven't seen yet. And it's the formula that says average, whoops, I made that real thick, didn't I? Sorry about that. Equals first score really, but first plus second divided by 2. And if there had been 3 tests, it would be the first plus the second plus the third divided by 3. And if there were 4 tests, we'd divide by 4, and on and on. So the average is always you divide by the number of items, in this case number of tests taken. So that's the formula that we're going to use, and we work with that right in the chart. Let's see, I'll put in here average, ABG. We'll put in the first test and the second test scores, and let's see. What numbers do we have for average? The average is 81. The first test we said was X. The second test is X plus 12. And when we put this together into the equation, we get average again is 81 equals X plus 12 divided by 2. Don't forget to divide by 2 in this problem. We're finding the average value. Again, it's now an equation, and to solve the equation we have to isolate the variable, but we have to prepare the equation by first clearing the fraction, clearing the denominator. And we're going to do so by multiplying each side by 2. And even on the right side I'll make it 2 over 1 so that we can see that the 2's will divide out. So what do we get here? 2 times 81 is 162. Equals X plus 12. Next we'll combine the 2 x's. X plus X is 2x. So we get an equation that's now 162 equals 2x plus 12. And now we're ready to isolate the variable by first adding negative 12 to each side. Want to clear that constant positive 12 out from there. And we're left with 150 equals 2x. Divide each side by 2. And now we're looking at 75 is equal to x, or x equals 75. Again, because we have our legend, I'm able to easily identify that x being 75 is the first test score. 75. And the second one is x, that's 75, plus 12, which is 87. Now together those two do not add up to 81. However, if we add them together, 75 plus 87, and then divide by 2, it should be 81 if we did this correctly. And you can work that out if you wish. I'm going to just go ahead and finish this by writing a sentence. And let's see, the question is, how many points did she score on each test? I'm going to write this. April scored 75 points. Whoa. Forgive me for that. That's pretty ugly. April scored 75 points on her first test and 87 points on her second test. Okay, there we go. And that's the third problem solved. That's focus exercise 8.